Okay, here's the antiderivative we're trying to evaluate right here. The fact that we have a square root symbol with something squared minus something tells us that we might want to use trig substitution. Of course, if this x was in the numerator, we could just use u substitution. When you're using trig substitution, you want to try to set up a right triangle where you're going to use one of these three trig ratios. And you like to end up with x in the numerator and constant in the denominator. So here's a little triangle, right triangle with this angle theta. The fact that it's x squared minus 4 means that x is going to be the hypotenuse, and we're subtracting the square of one of the legs to get the other leg. So by the Pythagorean theorem, this radical squared plus 4 squared will give us the hypotenuse squared. And now we can use secant of theta, which is the reciprocal of cosine, to get secant of theta equals x over 2. So x equals 2 secant theta. Dx would equal 2 secant theta tangent theta, d theta. And we don't have to do this now, but it's possible that we're going to have to substitute for theta when we find an antiderivative. So if we look at the right triangle, theta is the angle that has a tangent of square root of x squared minus 4 over 2. And while we're at it, why don't we see what we get for this radical after we make the substitution, x equals 2 secant theta. The whole idea is to get rid of this square root symbol. So the square root of x squared minus 4, substitute in 2 secant theta, which when we square it, we get 4 secant squared. Factor out the 4. Secant squared theta minus 1 is the same as tangent squared, trigonometric identity. Take the square root, we get 2 tangent theta. Okay, so now we have everything we need to make the substitutions into this indefinite integral. The square root of x squared minus 4, right there, is 2 tangent theta. D theta, or dx rather, is 2 secant theta tangent theta d theta. And x is 2 secant theta. And I've indicated what cancels out. These 2's, secant of theta cancels out. We're left with 2 indefinite integral tangent squared theta. This, the antiderivative of tangent squared is in your table of indefinite integrals. It's tangent theta minus theta. And now we're ready to substitute back in for theta. The tangent of theta is, look at the right triangle, the square root of x squared minus 4 over 2. And theta is the angle that has a tangent of the square root of x squared minus 4 over 2. Distribute the 2. These 2's cancel out. And finally add on the constant of integration. There is a possible antiderivative for this function right here. If you want to prove it to yourself, you can actually do it on Desmos. If we let f of x equal, big F of x equal our answer, if we take the derivative of that, we should get the original function. So here I've typed f prime, big F prime of x, and here I've typed the original problem. And if those graphs match or overlap each other, then this answer must be correct. And it does. There you go. Hope that helped. If you have any questions, post a comment.